ጤና ይስጥልን እንደምን አላችሁ የስልጣናችን ስድስተኛውን ክፍል ዛሬ በዚህ ቪዲዮ እናያለን። እሱም ወተርሼድ እንዴት ደልኔት እንደምናደርግ በQGIS እና የQGIS ፕላጊን ሳጋ ኔክስት ጄኔሬሽን የሚል ፕላጊን እንደምናደርግ እናያለን። ስለዚህ ወደ ቪዲዮ ጋር እንሂድ። Okay, in the last video we have seen how to download the DM by using QGIS plugin, open topography DM downloader, and we have seen how to project also. We can project either using raster. Here is projections. From projection we can choose warp or reproject this one, and we can use our unprojected DM, and we can change here targeted project. If we want to use this one we can project, but in the last did by right clicking and exporting save as. In the save as part I can give the name and I can change the coordinate reference system by using this part. So here it has already projected one. So here is the projection UTM zone 37N. And now let's see how to delineate watershed. How to delineate watershed by using QGIS and the plugin which is called SAGA Next Generation. The plugin. So let's go to start with the steps. There is a first step. The first step is to have area of interest. That means state area boundary. This one is our area of interest, Tarcha district, or we called it. The last we have dissolved one, which is Tarcha dissolve. And we have to check the projection from the workspace and all layers uploaded. So this projection must be the same with the DM as in the workspace. So I can check this one. So right click, properties, information. The information, it has projected coordinate system, UTM zone 37N. And the DM has the projection, which is, look here, it has projected coordinate system UTM zone 37N, and we have to also check the workspace here, the lower part of our map canvas, which is also projected one UTM zone 37N. Now the second step is checking projection, and then we have to clip our state area by using here the processing tools, clip raster by mask layer, raster, clip raster, here is clip raster by mask layer. So this one, this tool, either this one or you can use from the raster. Here is extraction, clip raster by mask layer, this one. So let me use this one, and my input is DM, and by mask layer is this one, Tarcha district or Tarcha dissolved one, and I have to give or assign the specific node data value in one click upward, and I have to give the name for the extracted file in my workspace. Okay, here is, I can give the name clipped DM. Okay, it can be TIFF it can be TIFF. Okay, you can save this one in the form of TIFF. Okay, and I can hit run. Yeah, clip them already masked. So we have to check here, unchecking others, and I have to see the study area district. So here is between this Tarcha district. Okay, now the next step is what we have to install the plugin. We have to install the plugin. Go to plugins, manage and then install plugins. Then I can write here SAGA. Right here SAGA. SAGA here is processing SAGA next generation provider. Okay, I have installed it, and then I can close this one and check here in the processing tool. Here is SAGA next generation. This one you have to check whether it was installed or not. Then what I do is the first step in the Watershed delineation is field sinks. So here is the field sink case. That means there are sinks and the peaks in the terrain, and or we can say that in the catchment or in the watershed. So this step can fill the sinks. So the first one is the A part, ADM. Without sinks filled, water enters the sink but does not leave. And the next B, I can say a dam with sinks filled, water runs over the sink and continue downstream. So this is what the idea of filling sink. So here I can write fill sink, fill sinks. So fill sinks here. The second one, fill sinks Wang and Liu under SAGA. Then my input is clipped DM, and other thing that I do is uncheck this one. That means flow direction and watershed basin, no need. Then I only generate flow direction. I only generate field DM, and I can give the name for field DM. So here in the catchment, I can give the name for this one. Only it supports .sdat. So I can give the name, which is field DM. Field DM. Okay, save. Then I can hit run. Okay, through our work we will use this field DM. Yes, we have now field DM, and you can observe also the difference. Field DM, the highest elevation value is this one, and the non-field one, the clipped one, has the elevation value is this one. Look the difference. And the lowest value and the clipped one and the field one has the difference. Now, great. Okay, let's do the next one. The next step is to derive stream order, or we write here Strahler Strahler Order. Strahler Order, this one, under SAGA. So what mean this one? I can click here, but what mean this one? I will show you. So here is Strahler Order is what assigning the numbers to stream. That means based on their order. So the first order has the lowest stream value, or two the same stream value joining at the same point and giving higher order. Here is also two the same ordered stream join at the same point and giving higher order. And you have to consider here the higher and the lower streams join, and they may not change the order. There is no change in order, and the same order streams joined and give the higher order. That means the higher order which has greater than one value or one order from the lower stream order. So this is what the idea of giving or assigning stream order. Okay, here is my input elevation is field DM, and I can give here the name for stream order or Strahler Order. Okay, you can run it. Okay, it was finished. And here is what amazing order. You can see here the order is from 1 to 7, but I can reclassify this one, or I can change the symbology. Right click, properties. Here is from the symbology part. The render type will be single band pseudo color, and I can change here the interpolation is discrete, and the mode of classification is equal interval, and I can classify this one like this. Okay, okay, then here is I can observe the streams, the stream orders and the streams. Look, this color has the highest order as we visualize. And the next step in this one is raster calculator to minimize the stream orders. I need only the streams above 4, so I can use only the orders from 4 to 7.1, and I will remove the orders below 4. Now I have to go to use the raster calculator, raster calculator, or I can write here raster, then I can select raster calculator. Now let me use this one. Here is the raster calculator. What I use is Strahler order or stream order, which is greater than or equals to, which has the stream order is 4, and I have to give the name, the output here, stream order greater than 4, stream order greater than 4. Let me give this one, and I can save this one. The output format is GeoTIFF. Okay, I can run. Here is. Now I can again go to properties, then change the render type to palette, and the random color is possible, and I can change this one to white color or no color. Let me use this part, no color, and okay, then I can change this one to deep blue color, especially watercolor, and I may change the transparency. There is the additional no data value can be 0, no need of other colors. Okay, I can then make it apply. Okay, here is. I may see it on the raster. I mean on the DM. On the DM, I can see here. This is the stream orders. Those have the order is greater than 4 value. That means 4 orders are there now. Before calculating raster, we have 7 orders now, but we have only 4 orders. So let's go to the next step, which is channel network. That means stream network generation. I can write here. That means it gives in the form of vector data or the shapefile form. So I can write here channels. Analyze channels. Then I can select this one, network and the drainage. So here is my threshold value is 4, and my input elevation is field 1, field dam. This one is field dam. Then I have to uncheck subbasins and Strahler order and the flow conductivity. Only I use channels. Here is this one, channels. I have to give the name. This you see here, save as type is shapefile. I give the streams, stream network. Stream network. Okay, you can save. Then I can hit run. Yes, it was complete. Now I can see here, unchecking this one, I can change the symbology and assign the value of color to blue, and I can add the stroke width around this one, and I can see, look this one. I can compare also this one with this, with the stream order greater than 4 with the stream network. Okay, the next step is to delineate watershed by using upslope area from the terrain analysis. Now I can write here upslope. So here is upslope area. What mean watershed is? So watershed is an area of land that drains water into a specific location or point. So here is the idea or the model which shows watershed or catchment. So here is the boundary or watershed divide is this dot, light colored dot lines. Those are what watershed boundary, or I say watershed divide. And here is sub-watersheds or sub-catchments. I can check this one like this way. If I want to use this part only, I can make the watershed boundary here. And here is what the idea of defining watershed is. The area of, or watershed or the catchment is area of land that drains water into a specific location or point. And this specific location or a point can be a water body. Here it can be lake, river, or wetlands can be this area. So all streams flow toward this water body. And the idea of what delineation is based on this model. So let's see from the upslope tool here. Before doing upslope area, we have to give the point. The point, that means pour point, water outlet. That means we have to give the outlet point. And I have to use this watershed. If I zoom it out this way, and if I give the point here and here, then automatically it generates to me the watershed. So I have to do this one by either creating the point or either right clicking here, copy coordinate. Here is the coordinate system. Then I can do like this one. If I do this one, or I can create shapefile. Let me do creating shapefile. Now here is no addition of something, but I can paste here the coordinates. This is X value and this is Y value. Okay, I have to remove this comma, and my input elevation is field DM. Then my method of watershed delineation or the flow direction is by using deterministic 8. This is also based on some of the principles. Here is this principle. That means 8 neighboring pixels are used to calculate the flow direction by using slope. So in case of this, when water flow to 1 towards 128 or towards 64 based on the slope generation. So based on 8 neighboring pixel value. So here, if you count, this is 8 pixel value. Then I can run this one by giving the name. Okay. Upslope area. Okay, I can hit run. Is it running? Yeah, it's completed. So here I can see here this area is selected, or the watershed is selected. For me, I can make this one to upward. Then I can do the conversion steps. And I can also create shapefile to get this out pour point, or that means water outlet points. You can do this one by going here, layer, create new shapefile layer. Then I can give the name in this point, pour point. Okay, it's a shapefile, and I have to select geometry type is multi-point or single point or point, and I have to give the coordinate system for this one. Now I'm using this coordinate system, and I can use this one, and then you can make okay. And finally, after this end, I can do toggle editing on, then add point, click add point by clicking this one, then I can add the point here. Here is I can add point. Here is one. Okay, then I can make it save, and then right click on it and open attribute table. Then adding here, I have to give X and Y coordinate. Now by doing this one, by open field calculator, from field calculator, here I can give here X coordinate, X chord, the output field type is decimal number. Then I can use here in the QGIS, most of the time we use $sign and only write X. Here is no problem, it shows preview is correct with number. So here I can click OK. Okay, I have generated X coordinate. Then I can repeat the step to generate Y coordinate. So open field calculator, then I can give the name Y chord, and output is the same decimal number. Then I give here the decimal, the $sign, then Y, and I click OK. Yes, we have generated this one. And now I can copy this one. I can saving this one. After saving this one, I can click here and I can copy what the generated X and the Y coordinate, and then I can check this one, and I put input is elevation on this one, field DM. And now this is very interesting part to copy this one. You can right click or Control C, copy cell content, then I can paste here, Control V, and the same way I can do this one, and I can generate finally the watershed. Now I have to continue with the next step. Okay, now I have to change this one to polygon or to vector data. Then I have to write here, or I have to go to raster. From the raster, there is conversion. Here is, I can select polygonise raster to vector. Then my input is this one, that is upslope one. the upslope one, upslope area. Then I have to give the output as default values are taken, and then I have to save it in my folder. Then I have to give here what catchment. Okay, I can do like this. And so here is other thing that I can do is hit run. Yes, here is catchment. I can overlay streams on it, and I can clip now the watershed from stream network. Now let's go to vector, then job processing, then clip. My input is stream network, and my overlay layer is catchment. And finally I can give save to file. Okay, watershed, okay, save, then run. Yes, watershed. This one is what I did. Okay, catchment. Okay, here is. Now I have to change the symbology, this one to blue. Okay, and the stroke width can be this one, and I can apply. Here is. This watershed is already delineated from the given DM. Now I can make it either hollow or change the color, or I may change this color to this one or this way, and I may do more things. So this is what the steps to delineate watershed by using QGIS. And finally, you may make this one as a map or as a report. Or if you want to generate sub-catchments from here, from this point to this one, by using what the 4-point model, by putting the points on the what the joint, in the joint, or when is a two different streams join together. See you in the next video. Thank you very much. So don't forget subscribing my YouTube channel. I will come with the video which is classifying land use land cover by using QGIS in the next coming video. So don't forget subscribing my YouTube channel. Thank you very much. Bye bye.